Now let me explain to you the definition of rectilinear motion. Rectilinear motion means the motion of a particle along a straight line. If a particle of mass m is moving in a straight line under the action of variable force F, that means the force F here is fixed, then it's not fixed, then the equation of motion is given by m d2x dt2 is equal to F. This is by Newton's second law of motion, where x is the distance covered in time t from the start. So let us discuss the motion of the particle under different variable forces F. The first one is this: force of repulsion varying as displacement. That means in this case the force varies as the displacement or is proportional to displacement. Repulsion here means that the force is that the particle is moving away from the center of attraction. So now from this figure you can see that if I take O to be the fixed point, this is a fixed point, and P to be the position of the particle at any time t whose distance from O the fixed point to be x, and let us take A to be the initial position of a particle whose distance from the fixed point is A. Now here, since the condition here is a force of repulsion varies as displacement, it means that F is proportional to mx because force is equal to mass into acceleration. So now this should be proportional to mx, that is F can be written as m mu x. Now what is force? Force is equal to m d2x dt2. So replace it by that one. So m d2x dt2 will be equal to m mu x. Now here the equation of motion is this one. M d2x dt2 is equal to m mu x. It is positive here because it is a case of repulsion, not the case of attraction. Had it been the particle is attracted towards the center, then in that case it will be the case of then it will be negative here. Now simplify, can be cancelled, then you'll see that you'll get d2x dt2 is equal to mu x. But we know that d2x dt2 is same as v dv dx. This is the equation of acceleration. Now this one can be expressed as v dv dx. So you replace this one by v dv dx here, which is equal to mu x. Now you can transfer by method of separation of variables, you can transfer this dx to that side, then you'll get v dv is equal to mu x dx. Then from here you'll see that on integrating this one, you'll get v square by 2 is equal to mu x square by 2 plus c1, or v square is equal to mu x square plus c. You cross multiply this one by 2, then you'll see that you'll get 2c1, but 2 is a constant, c1 is a constant, so you can replace it by another constant c. Let us name this as equation 2. Now let us consider the case 1. Suppose a particle starts from rest at a distance a from O, that means this one. So suppose the particle starts from rest whose distance is from O is this, x is equal to a, t is equal to 0. If it starts from rest, that means the velocity also will be 0. So from this equation 2 now, so using that condition that at A, x is equal to A, v is equal to 0. So if you substitute it here, then you'll get v is equal to 0 square is equal to mu into a square plus c. So finally you'll get c is equal to mu a square. So after getting the value of this constant c, or evaluating the constant c, then you can substitute it again in this equation 2. So v square now become mu x square minus mu a square. Now take the square root of this one. V is equal to square root of mu into x square minus a square. Again positive sign here, since it is a case of repulsion, that means x increases as time increases. So therefore we are taking the value of this velocity here as positive square root of this one. And then you can replace it by dx dt is equal to, since velocity is equal to dx dt, replace it by that one. You'll get dx dt is equal to this, cross multiply, then by method of separation of variable, then you'll get dt is equal to 1 by root mu into dx by square root of x square minus a square. Now if you integrate this one, on integrating this one, let us see what will you get from here. So you'll get integral dt is equal to 1 by root mu integral dx by square root of x square minus a square plus some constant, say c prime. Now This is equal to 1 by root mu. Now what is the formula of integral dx by square root of x square minus a square? Had it been a square minus x square, that will be sine inverse of x by a, but since it is square root of x square minus a square, the formula of this one will be cos hyperbolic inverse of x by a plus some constant c prime. So t here you'll get it as 1 by root mu into cos hyperbolic inverse of x by a plus c prime. Now we need to calculate this one. At a again, at that initial position a, that is this one, what is t? T is equal to 0. That means when x is equal to a, t is equal to 0. At a, x is equal to a, t is equal to 0. So using this initial condition, we can find out the value of c prime. So substitute here, this will be 0 is equal to 1 by root mu cos hyperbolic inverse of x, a by a. Replace x by a, then plus c prime. So cos hyperbolic inverse a can be cancelled. You'll get cos hyperbolic inverse of 1. But what is cos hyperbolic inverse of 1? It is 0. So you'll get here it is 1 by root mu. This will be 0 into 0 is equal to c prime. Plus c prime, this will be equal to 0. So you'll get the value of c prime also. C prime is equal to 0. And here you will see that equation, that is this equation, this equation now becomes what? It will be t is equal to 1 by root mu cos hyperbolic inverse of x by a. Then from here you'll see that you'll get root mu into t is equal to cos hyperbolic inverse of x by a, which gives you root mu t, cos hyperbolic of root mu into t is equal to x by a, or x is equal to a cos hyperbolic of root mu into t, which gives you the relation between distance and time. This one will give you the time taken by the particle to travel at time t from that initial position to that center of attraction, and x will be the distance given by this relation. So this is for case 1. Now let us discuss case 2. Case 2, now suppose the particle is projected at a distance a with velocity v1 towards O. So now in this case, suppose a particle is projected towards O, whose distance from the fixed point is O, and the velocity here is v1. So now let us recall that equation 2. We have in equation 2 as v square is equal to mu x square plus c. Now at a here, since at a the value of x is equal to a and velocity is equal to v1. So you replace this one v by v1 and x by a to evaluate this constant c. So on substituting that one, then you'll get c1 is equal to v1 square minus mu a square. Now this equation 2 becomes what? It will become v square is equal to mu x square plus, what is the value of c1? You replace it by this, so you'll get v1 square minus mu a square. And on simplifying this one, you'll get v square is equal to mu into x square minus a square plus v1. Now again we represent the velocity, and it can be written as dx dt, the whole square is equal to this. Now here dx dt, take the square root of this one. And on taking the square root, in this case it will be negative square root. Why? Because the particle is attracted towards the origin, since it is projected towards the origin, and as t increases, x decreases. So therefore, the velocity here will be negative. Now let us simplify this one and separate the x variable and the t variable on one side. So we'll get dt is equal to minus 1 by root mu dx by square root of, simplify the term inside this one, x square minus a square minus v1 square by mu plus, then integrate it, and on integrating then you'll get some constant c2. So you'll get dt on this side minus 1 by root mu integral dx by square root of x square minus a square minus v1 square by mu plus c2. Name this as equation double star. So now let us see this one. Consider this one will have subcases. That is, this equation will have to consider subcases. There will be 3 subcases for this one in order to evaluate the value of this integral. So let us first see what will be that subcase 2(1). That is, if this term inside the bracket a square minus v1 square by mu is greater than 0. So what will be the condition for this one? So if this is greater than 0, then in that case, this on integrating this one, you'll see that you'll get t is equal to minus 1 by root mu. Again, it will be the form dx by x square minus some constant term here, and that one will give you cos hyperbolic, again inverse of x by, what is a here? It is that 1a square minus v1 square by, it will be square root by mu plus some constant c2. So you'll have this one now as t is equal to this one when a square minus v1 square by mu is greater than 0. Now again, to evaluate this constant c2 here, what you need to do is at the position a, again we know that x is equal to a, t is equal to 0, because at this position, the initial position of the particle before the particle is projected, the initial value of x is a and t is equal to 0. So using that initial condition, x is equal to a, t is equal to 0, substitute it here, then you'll get the value of this c2 as, substitute here x by a and then t by 0, then transfer this one to that side, you'll get c2 is equal to 1 by root mu cos hyperbolic inverse of a by square root of a square minus v1 square by mu. Then substitute it here and then you'll get the relation between time and distance. So finally, you'll get the value of this one. After getting the relation between time and distance, then you'll get the relation of x in terms of t also to evaluate the value of x. So that one will be for subcase 2.1. Now for subcase 2, suppose the term inside this bracket, that is from this equation double star, a square minus v1 square by mu is equal to 0. Then in that case, it will reduce to just this one. Integral dt is equal to minus 1 by root mu dx by square root of x square plus c2. So this will give you t, this will be t, and integrating this one, you'll get minus 1 by root mu log x plus c2. Again here you have to use the initial condition at a, that is t is equal to 0 when x is equal to a. So here you evaluate this c2, it will be 0 is equal to minus 1 by root mu log a plus c2. And simplify this one, you'll get c2 is equal to minus 1, it will be 1 by root mu log a. So we'll get the value of c2 as 1 by root mu log a. So finally substitute it here, then you will get it as t is equal to minus 1 by root mu log x plus 1 by root mu log a. Simplify this one and using the properties of this one logarithm, then 1 by root mu can be taken out. Then here you'll get log a minus log x, which can be written as a by x. So here you will see that you'll get this one as t is equal to 1 by root mu log a minus log x, which is equal to 1 by root mu log of a by x. And then this gives you the relation between t and x. Now to get x here, you can raise this one to e to the power, the exponential form, that is e to the power t will be this one, it will be e to the power this one into log of, log and e will be cancelled. So here you'll get it as x is equal to a by e to the power root mu into t. So this will be the relation of x and t now. In order to evaluate the value of x, for this case, when the term inside this bracket a square minus v1 square by mu is equal to 0. Now for the last case, that is this one, for subcase 3, when a square minus v1 square by mu is less than 0, then in that case you have to express this last equation. You can express it in this way: x square, now bring this one minus into minus, will become plus v1 square by mu minus a square. And the formula for this one is, this is it will be, if you integrate this one, it will be some c3 constant here, then it will be minus 1 by root mu. The formula for this one, it is sine hyperbolic inverse of x by square root of v1 square by mu minus a square plus c3. Again, by using the initial condition at a, x is equal to a, t is equal to 0. So finally you'll get the value of C3 as 1 by root mu sine hyperbolic inverse of a by square root of v1 square by mu minus a square. Here you substitute x is equal to a and t is equal to 0 in order to get this C3. So you'll get the value of C3 as this one, and then substitute it here, then you'll get the value of t now is equal to minus 1 by root mu sine hyperbolic inverse of x by square root of v1 square by mu minus a square plus this one 1 by root mu sine hyperbolic inverse of a by square root of v1 square by mu minus a square. So this gives you the relation between t and x, or to evaluate the value of t knowing the value of x. But on simplifying this one, you can also transfer this one to this side, which is independent of x. So t plus, or I can, since 1 by root mu is common, so it will be root mu t, then plus sine, sorry, it will be, this is minus, this is plus, so you can transfer this t to this side and bring this one to that side, then you'll get sine hyperbolic inverse of x by square root of v1 square by mu minus a square is equal to this one. It will be sine hyperbolic inverse of a by square root of v1 square by mu minus a square, then minus root mu into t, root mu into t here. So from here you see that in order to get the relation of x, so you transfer this sine hyperbolic inverse to this side, so you'll get x by square root of this one will be sine hyperbolic of this whole term, and then after that cross multiply this one to this side, you'll get x. So finally after this one transfer the sine x inverse to that side, then you'll get that x is equal to square root of v1 square by mu minus a square, that is this term, into sine hyperbolic of whatever the term on this side, so it will be inside the bracket, sine hyperbolic inverse of a by square root of v1 square by mu minus a square minus root mu into t. So this gives you the value of x when the term a square minus v1 square by mu is less than 0. So this will give you the equation of motion of the particle when the force of in this case the force of repulsion varies as displacement, or the force of repulsion varies as the distance. So go through again this thing, this explanation. If it is not clear, please let me know.